We know a tremendous amount about how typical brain development occurs from the prenatal period through the first few years of life. But in terms of abnormal brain development, that's trickier. It depends on the population. When it comes to autism, it's a big mystery right now. If you look at the literature with kids with autism, not infants, and you look at MRI scans, you look at autopsy specimens, you look at any number of things, nothing consistently pops out as being a culprit. And that's funny, not funny haha, but ironic, because autism is defined as social communication deficits, repetitive behaviors, and language problems. Three things that we know exactly where they are in the brain, and yet the whole brain seems to be implicated in autism, which is a funny, is a challenge to scientists. We think what's going on in autism is a disconnection problem. The brain isn't getting wired up correctly. It's as though area A is not speaking to area B when it really does need to do that. So, but this is speculation on our part, and the reason is that our knowledge of brain development, as rich as it is, a lot of it is based on animals, and there's no animal model of autism. I wouldn't know what an autistic mouse looked like, for example. So we're stuck studying the human. And then we are limited in how we can study the brain in the human. So we have a couple of tools that we can use in the first couple of years of life. We can record the brain's electrical activity. We can record the brain's metabolic activity, blood flow, for example. And in some cases, we can record magnetic activity. That's a very high-tech thing that no one has done much on yet, but it's possible. When kids get older, after 4, 5, or 6, we can start doing magnetic resonance imaging on them, but not when they're younger. But again, it's harder to do that in a young kid than an adult. I can get you to lie on an MRI scanner for a few hours, maybe. I can put electrodes on your head and you can sit there calmly and do my task for an hour. But when you're dealing with a 1-year-old or a 2-year-old, you have like 4 minutes to do this. So we have a lot of challenges, and that's limited how much we know about brain development in both typically developing kids and kids who are going to have problems.